Welcome my dear student. So in this lecture series I am going to solve some application based problem on the concept of impulse momentum relation. Okay. So applied in the case of collision. So let us say start with the first situation where there is a ball which is being dropped from a height of 8. Okay. After the impact the particle becomes horizontal. Let us say it will hit the floor, hit this wedge which is at an angle alpha. So once the particle reaching on this part, so let us say it is moving with a downward velocity v naught. Now what is the v naught number? So v naught equals to under root 2gh because it is falling from the height h. After it impacts, it becomes horizontal. That means finally let us say it is moving with velocity v in the horizontal direction. Now whenever you are asked to calculate the e number, so make sure that e can be applied only along the line of impact. Okay, so what is the line of impact? So this is the line of impact. Why? Because along that direction the normal force is acting. So this is called the line of impact. Okay, so V naught has two components. So one component is along this direction, that is equals to V naught cos theta. Okay, another is the V naught sin theta is in this direction. So this is the V naught sin theta number. Okay, now along the line of impact, the ball will rebound back with a velocity which is equals to E times V. That means in this direction the velocity becomes E into V naught cos theta. Okay. Now finally what is happening? V is in the horizontal direction. Okay, V is in the horizontal direction. So if I say this is the particle which is moving with a velocity V, it has two components of velocity. One is E V naught cos theta. Another is the V naught sin theta. V naught sin theta. Now what about the angle? So this angle is taken theta. That is given. Okay. So what I can say that V cos theta, so V cos theta, that should be equals to V naught sin theta. That should be equal to V naught sin theta. Or what I can write, V should be equals to V naught tan theta. Okay. And for the second situation, E V naught should be equals to V sin theta. Okay. So V sin theta should be or equals to E times V naught cos theta. Okay. Now put the value of V naught. So V naught is how much? V equals to V naught tan theta. So here I can write V naught into tan theta means sin theta by cos theta. So 1 upon cos theta into sin square theta. 1 upon cos theta into sin square theta. That should be equals to E V naught cos theta. E V naught cos theta. So V naught cancels out. So ultimately I am getting E should be equals to sin square theta by cos square theta. That means it is equals to tan square theta. Okay. And it is equals to tan square theta. This is the tan square theta. So what is your answer? So E should be equals to tan square theta. That is your answer. Okay. So let us do this situation where the ball is being dropped from a height of 10 meters. Now you are asked to calculate the speed of the wedge after the impact. Okay. So the wedge is also getting some kind of velocity. Why? Because the normal component of force acting on the block is in this direction. Okay. So that is the impulsive type force. So let us say the N is the impulsive force. Now N has two components. So on the ball, the N is acting in this direction. Okay. So because of this, the N has two components. One can say this angle is equals to how much? This is also 37. So N becomes equals to this angle is cos 53. So N cos 53. Cos 53 degree. And this N sin 53. So this N sin 53 number is the impulse along the y direction. So that will change the velocity along the y direction. So let us say after the impact, after the impact, the ball is moving upward with the velocity v1. So the component of velocity v1 along the upward direction. And after the impact, ball has the horizontal component of velocity because the horizontal impulse is let us say v2. Okay. And finally, the wedge is moving with the velocity v. Okay. So what I can write that the component of impulse for the wedge is how much? That is equals to N cos 53 in this direction. N cos 53. Okay. So now I can write the three equations for the ball along x and y and for the wedge along the x direction. So if I write the wedge equation, so for that wedge, integration of N cos 53 dt, that number is equal to 2v, final momentum only. Okay. So along y direction, if I apply for the ball, so it should be equals to minus minus n sine 53 dt integration. That should equal to final momentum. Final momentum is equals to v1 minus initial momentum minus root 2 gh. Okay, ball having a mass of 1 kg, so that equation. Similarly, along the x direction, so this is for the y direction. Similarly, this is for the x direction. So x direction of impulse is n cos 53. So integration of n cos 53 dt, that will give the value of v2 again. Okay, so these are the three sets of equation, and also you have to write the equation for E also. Why? Because number of unknowns are G, V1, V2, and along with the N. Okay, so 4 unknowns are there. So you have to write the equation, third equation, the fourth equation, that is for the E. So what is that E equation? That is the velocity along the line of impact, change in velocity. So for that, what is the velocity component? If I take along the line of impact, so if I, this is the weight, so this is the line of impact perpendicular to this. Okay, so I have taken that the ball is moving along this direction with a velocity v1, final velocity, and there is one component velocity v2 along this direction. Okay, so this angle is 53 degree. So component the final velocity along the line of impact should be equal to how much? v1 cos 37 plus v2 cos 53. So v1 cos of 37 degree plus v2 sine of v2 cos of 53 degree. Cos of 53 degree. That is the final velocity minus initial velocity. Minus initial velocity is how much? That is v cos 53 degree. Why? Because this is the initial velocity is along that direction. So this is the v number. Okay, that is root 2 gh number. So it has a component along this direction. So what is that angle? That is 37. This is 53. This is 37. So v cos 37. V cos 37 is along that direction. So not that velocity. So v2 is the velocity of the wave block, and v1 is the velocity of the wave. So wave is moving along that direction. So wave is moving with the velocity v along that direction. So component of velocity, so this angle is 37 degree. So sine 37. Sine 37 with a minus sign, so ultimately become plus. So v sine 37 degree. This is the numerator part, and denominator is u1 minus u2. So u1 is how much? That is the initial velocity root 2gh. Root 2gh. And component of root 2gh, so this angle is 53. So 2 root 2gh is cos and sine. So this is the 2 root 2gh sine of 53 degree. Okay. So E number is given as 0.5. So this is the fourth equation. So solving of this 4 equation will give the value of final answer for D. Okay. So this is a typical problem where you have to apply the concept of impulse momentum relation along with the equation of E, and mind it, whenever you are writing the equation of E, so E has to be written only along the line of E. Now the same problem can be much more complex if I take the effect of friction. Let us say on this wedge of capital mass M, there is a friction is there. Okay, the ball is being projected in this direction. So you are asked to calculate the speed of the plank after the impact. Now once the impact is taken place, now that means there is an impulsive force. There is an impulsive force. If I draw the free body of the ball, so let us say the ball will move along that direction because there is the impulse force, N is the impulse force. Okay, so with a velocity component that is equals to initial component is v naught, so it will reflect back. So if I say the angle made by this ball, so if I say the ball is returning back, the velocity, let us say the ball is hitting initially. So ball has two component of velocity. One is ux and one is uy in the downward direction. Okay. So once the ball is returned back, it will be coming back with the velocity equals to e times of uy. Okay. So along the impulse only the velocity will change. So e times the uy, and because of friction, again the friction becomes impulse. On the ball, there is a friction acting on this direction, that is equals to mu times n, and because of that, the final velocity will be along that direction, let us say ux prime. Okay. So for this plank, what I can say for this plank, the friction is in the forward direction. So here the friction is in this direction. So that is equals to mu times m. So that is impulsive force. This is impulsive force. That is also impulsive force. So write three different equations for this impulse. So along this vertical direction, what you can write, integration of n dt should be equals to m into e into uy minus of m into uy. Okay, this is the final momentum, this is the initial momentum. So ultimately I am getting m into e into uy plus m into uy. This is the equation number 1 for the ball along the y direction. Similarly, for the ball along the y direction, what is that? That should be equals to friction is mu n. So minus mu n dt along the x direction I am applying the equation mu n dt, that should be equals to m into ux prime plus, not plus, it should be minus m into ux, because ux is same direction. Okay. Now ux and uy is known. So since ball is coming, let us say the ball is hitting at an angle theta is given. Okay, so theta is given. So this ux should be equals to v naught cos theta. I am writing over here that ux should be equals to v naught cos theta, because theta angle should be given. So ux is known and uy is what? Uy is v naught sin theta. That is also known. Okay. So these are not the unknown. So this is the equation number 2. I am writing for the x direction impulse relation for the ball. Similarly, I have to apply the y x direction impulse equation for the Planck also. So what is the frictional force? That is equals to mu n into dt. That should be equal to final momentum. Let us say that after the impact is over, it is moving to the velocity v prime. So that should be equal to capital M into v prime. Okay. So here the unknowns are only here ux prime and v prime. Ux prime and v prime and m. So ultimately what I am doing, so I have to solve these three set of equations. So what are the number of unknowns I am listing over here? So one number is ux prime, that is unknown. One number is v prime, is that is also unknown, and another number is capital N is also unknown. Okay. So what you have to do? You have to first multiply equation number 1 with mu. So first multiply equation number 1 with mu. 1 into mu. So it becomes mu n dt. Now we add with the equation number 2. Add with equation number 2. Okay. So that gives one relation. Similarly, there is the answer for the third equation also. So if you solve these three equations, then you can get the idea of what is the value of v prime. You can calculate it. Okay. Or you can calculate the ux prime velocity. All these things can be known to you. So this is how you can apply the concept of impulse moment relation for solving some difficult type of problem where the effect of friction is also coming, which is impulsive. The effect of normal force is also coming, which is also impulsive in nature. Okay. So take care about all the impulsive force along the proper direction, and accordingly you give the direction of momentum along that direction. Okay. Once you write the equation properly, then by addition or subtraction you can get the answer. Okay. Hope you understand this. Thanks for watching the video. If you like it, please subscribe my channel.